Alright, this is Algebra Notes number 20, doing finding slope and rate of change. Make sure you put your name, date, and class period. The essential question says how do you find the slope of a line and interpret slope as a rate of change? And in order to find the slope of a line, you will use your slope formula. And if you're interpreting change, you have to base it on a situation and tell how things are changing. Alright, we have a vocabulary word of slope. Slope is the ratio of the vertical change to the horizontal change, which is called the rise over the run, between any 2 points on a non-vertical line. We will say rise divided by the run all the time on the graph for slope. And we will also have a formula that I'll give you here in just a second. But realize slope is rise over run when you're looking at a graph, and it's the stair steps of the graph. I'll show you in a second. Rate of change says compares a change in one quantity to a change in another quantity. This is usually seen rate of change as the in story problems that we write. They won't call it slope. They'll say how much is this changing, or the rate of change. Dealing with money and gas and all that, various things. If we deal with first the examples here on the front page, it says plot the points. So they give us 2 points and then draw the line through them. Without calculating, tell whether slope is a line is a positive, negative, zero, or undefined slope. So if I take my first point, I'm going to plot 0, negative 4. I'm sorry, 1, negative 4. 1 is to the right, and then negative 4, 2, 4 should be right here. And then I have 5, negative 8, so 2, 4, 5, 2, 4, 6, 8 is in that location. And then they want me to draw my line. These are continuous, so make sure you draw your line. It says a line. And I'm going to go to my second one. I'm going to go ahead and plot it before I have to decide which one of the 4 graphs it is. So here I have negative 7 and 7 and 1. Negative 2 and 1. Okay, so here is the graph. This one. It's supposed to be an arrow. There we go. And then let me plot the third one down here. It has 2 and negative 10. Oh, this is counted by 4s. So that means this is an 8. So 10 would be in the middle. Good lordy, that one's tough. And then 12, 2 for 12, and positive 10. 10 right there. Okay, and let me draw the line for this one. Make sure you have arrows. Okay. So I have plotted my points, I have drawn the line, and now it tells me I've got 3 options here. It says tell whether the slope of the line is a positive, a negative, a 0, or an undefined. So there's 4 options. Positive and negative are usually the easiest ones to grab. If I'm looking at these, this is telling you the direction of the line, which way the line is moving. I always read my graphs from left to right, but if I look at the first one, this one, as I look at it, is in general, as I go across, go from left to right. We're in the United States, we move left to right. This one is progressing in a downward motion. Even though it's going up to the left, it's going down to the right. So both of those, this is a negative correlation or negative slope. Okay. If you look at the bottom one, notice it's, as I go left or right, move the ruler across, it's going up Therefore, since this graph is going up, this would be a positive slope. Okay, so this one appears to be going down. This one appears to be going up. So I have our two different types of slope. Now this third one, as I move across, that line is just staying exactly where it's at. It's not moving up or down. Okay, remember slope is a rise over run, so it's not moving up or down. It's just sitting there. It's like a lazy person just sitting in a chair. It's not doing anything. Well, that means it's either a 0 or an undefined. Well, for this one you can't really guess. I'll just have to tell you straight out. This is a 0 slope. Okay, because this one is moving like crazy, but it's not going up or down. It's not rising. An undefined slope, since we do not have another graph, if I was to etch it here to show you, if I drew my x-axis, and my black marker is running out of ink here. If I drew the x-axis and the y-axis, an undefined slope is the opposite of this one. Okay, realize this is a horizontal line. The opposite of being horizontal is to be vertical. These are those special lines. Vertical means I'm going in this fashion. Okay, straight up and down. And that makes this an undefined slope. You can't find it. And you'll see it in the formula when we use it. Alright, if I go to the next page. Example 2 says we want to find the slope of the line that passes through the given points. With these examples, I have a graph given to me, so I can actually use rise over run, which is stair steps. What I want to do is I want to go from the lower point and I want to make a triangle going to the top point. So I'm going to follow the lines that are on the grid, making a triangle, going from one point to the next point. Next, I want to count from the bottom. The vertical line here has 1, 2, 3 spaces, and then on top it has 1, 2, 3 spaces as well. If I tell you that the slope, which isn't always an elm stands for slope for some reason. Let me put that over here. That's the letter for slope, is elm. Is always the rise over the run. The rise number, you must rise up before you can walk away, so the rise comes first. The rise is a 3, and the run is also a 3, which reduces to a 1. So my slope is 1. On the second example, this is on a horizontal line. I'm trying to get from -3,4 to 0,4. Am I going to rise up at all? I'm trying to rise up before I can run. I can't rise up at all, so that means the rise is 0, and then the run, well, moving over 1, 2, 3. Well, 0 over 3 is the same thing as 0, so my slope is 0 on this horizontal line. That's also why over here we already encountered that when we had the horizontal line. They said they had 0 slope. Okay, it already said we had 0 slope. Horizontal line. Here's a horizontal line, and here's why we have a 0 slope. Alright. When we don't have a graph given to us, things change. Because we have coordinates, and there is a formula that you must know. I'm going to write it in the side over here. Slope formula. Okay. And this is where my m comes in all the time. M equals. And I'm going to write it down first, and I'll start working through it so you can see it. Okay. Okay, so here's our formula when we're given 2 points. And that's what my point values look here. I'm going to plug them into my formula and do the math. If I look at my first coordinates, the first coordinate, I'm just going to label it x1 and y1, so that the x1 is the 2 and the y1 is the 5. And then on the second coordinate, I'm going to label the 3 my second x, so that's x2, and the 0 is going to be my second y in my coordinate. Because remember, your coordinates are all an x and a y coordinate. I'm going to look at my formula. Okay. Calls for y2. y2 is a 0 minus y1 minus y1, that is a 5. Okay. Then on bottom it has x2, which happens to be the number 3, minus x1, which happens to be the number 2. So I have my first coordinate, my second coordinate, which was the green, in the first position, and then I have my first coordinate in the second position. So it's like they crisscrossed. Alright, I need to do the math here, and I can do it in my calculator. And I want to do it all at once. If I do this, I want to put the top in parentheses and the bottom in parentheses. So that I have 0 minus 5, close your parentheses, and then the divide button. Parentheses, 3 minus 2, and close your parentheses. And I do want this to be a fraction if possible. So I'm going to have the math, and I'm going to frac it. So that I have the frac there, and enter, and it gives me -5. That's my answer. So my slope is -5. Okay, I'm going to practice this again on the second one. We'll label my points x1, y1. And the second coordinate, I want to say, is x2 and y2. And my formula is m equals okay. So it calls for y2 first. If you look over here, y2 minus y1. y2 is 6. y1 is -8. In the denominator, it has x2 minus x1. x2 is -3. x1 is 4. Okay, so here we go. Equals, I'm going to put the top in parentheses and the bottom in parentheses. Oh. Okay, so make sure you have parentheses around your numbers. Make sure I have it right. Okay, remember to math frac it. And I get slope is -2. Okay, last two examples down here at the bottom are interesting problems. They're a little bit different type of format. So if I start out by what I've been doing, labeling my coordinates, and then thinking about my equation that was right up here. If I fill it in, well, let's see here. I know the m. The m is given to me, which is 1/2. Equals, and then the formula calls for y2 minus y1, so that means that'll be 7 minus the y. Oops, sorry. And on bottom it'll have 2 minus x1, which is 0. And I'm left with trying to figure out this problem. 2 minus 0, does that equal 2? Yes, it does. So 7 minus what number equals 1? Because here's our problem. Well, if I think about this backwards, I would say that y is equal to 6 because 7 minus 6 is equal to a 1. If I try this same logic on the second problem, let me put my values on here. They tell me that the slope is 3, so my m will be a 3 is equal to, and here it's y2 minus y1. y2 is a 2, y1 is a negative 7, x2 is a 1, and x1 is an actual x. Well, the first one, it was a fraction. That was easy for me to do because I just looked straight across and everything matched, so I was able to just take the top and solve it. On the second one, it's not so nice. Okay, so I'm going to imagine, I'm going to back up just a second. Imagine that this is actually 3 over 1, because I actually need to do a little bit of math here. Think about 8th grade when you had fractions equal fractions, and I'm going to cross multiply. I need to find out what this is before I cross multiply. So if I'm looking at this, 2 minus a negative 7. 2 minus negative 7 comes out to be a positive 9. So this equation is actually 3 over 1 is equal to 9 over 1 minus x. Okay. To get from 3 to 9, that's not so nice, so that's where I'm going to actually cross multiply. 1 times 9 is 9, and then I need to do 3 times this 1 minus x. 3, and I'm going to put this in parentheses, 1 minus x. Okay, so here we go. We have an equation. Let's go back to our y equals. Let me clear those things off. y1 is a 9. y2 is 3 parentheses 1 minus x, and I'm going to close my parentheses. I want to solve this, so I'm going to go to the table, and I'm looking for where it has a 9. Right there is my 9s, and the x value is a negative 2. And here x is equal to negative 2 when that happens. Okay, that is it. Make sure you answer your summary, and I'll see you in class.